Hi chaps, welcome and thanks for watching. Here is the breakdown of this episode. Please use the chapter markers if you want to skip or fast forward. We will have a closer look at the XIAOMI Mi Router 4A Gigabit Edition today. We'll test the Ethernet switching and routing performance plus the Wi-Fi performance. First with the stock firmware and then with OpenWrt. But before we flash the device with OpenWrt, we will have a look at some, well, let's call it specifics of the original firmware. Stay tuned. In my last video, I compared 3 routers and how they perform with OpenWrt. Many of you left me comments on YouTube. Thanks for that. Asking if I would want to have a look at the XIAOMI Mi Router 4A. I hope that I do pronounce this correctly. Leave me a comment. This device costs roughly $30 and has MediaTek hardware, so it should be the perfect fit as a home router. So I was curious myself and hence I bought one on Amazon. That means that I am not in any way affiliated with XIAOMI. They did not provide me with a device and they are not paying me to do these tests in any way. First look at the device. It's quite small, really flat if I compare it for example to the Archer C7 here. It has 4 antennas and it has 3 gigabit ports, 2 for the LAN and 1 for the WAN. It does not have any USB ports. There are no wall mounting holes or anything, so either you put the device on a table or a desk or shelf, or you need to 3D print clamps or the like if you want to wall mount it. It's really small or rather flat. Will it have enough juice to provide gigabit connection? Let's not judge a book by its cover, but see for ourselves. Cool, so let's have a quick view at the installation and the user interface. When you plug the router in for the first time, then it will act as a DHCP server on the LAN interface and will be reachable on the 192.168.31.1 address. The first thing that it asks you to do is that you select your region and agree to their terms and conditions. I suggest you read those terms and conditions. It will become clear why later in the video. Once I have read and accepted the conditions, I will then have to put in a password for the Wi-Fi and web interface, which will be printed out in clear text on the next screen. So just make sure that nobody is watching over your shoulder while you do this. The router reboots, and once I reconnect to its IP address in the web browser, I am greeted with this QR code over here, which would let me download an app to access the router remotely. I'm not doing this, I just want to use the web interface. Here you can do stuff like manage the Wi-Fi, some very basic network settings, activate quality of service, DHCP and dynamic DNS or VPN. The user interface is really slim and down to earth with the most basic settings here. One thing intrigued me though. Look at the URL. That does look like OpenWrt. Does the router already have OpenWrt installed? We'll see later. Before that, let's get shell access. The documented way of installing OpenWrt on that device is actually to use an exploit called OpenWrt Invasion, which you can get from GitHub. The link is in the description. The easiest way to use this is to run it in Docker. So let's do that quickly. The container is built, and when I run it, it asks for the router's IP address and the session token, which I can just copy from the web interface. Once the exploit has ran, then we can telnet into the router and do stuff there. Let's first do the speed tests and then we will look around a bit on the device to see what's under the hood. Guys, if you want to see a more detailed video on the flashing process, then please check out that video of fellow YouTuber Hoddy, who also wrote a guide and more importantly, pre-packed the PXE boot utility in order to unblock the router on his blog. Please do show him some love and give his video a like. Many thanks guys. The test scenario in my last video consisted of a combination of HTOP running on the device itself in order to monitor the impact on CPU on the router and iPerf or iPerf3 from the outside in order to measure throughput. We don't have HTOP on this device, but we have top, which is not so colorful, but it will do the job. So let's go. First scenario. I switched off the DHCP server on the router and then connected both LAN interfaces to my LAN on one side and to my laptop on the other. Now I can run a speed test from one LAN port to the other, which should not trigger routing, but rather happen on the switch hardware. As you can see, we get quite decent performance here. Top shows no CPU load, just as expected. There is switch hardware inside the device. That's good. Let's do the next test. In order to test routing performance, we will run the speed test between the LAN interface and the WAN interface. Going from one subnet to another will force the device to use the routing functionalities. iPerf3 shows really decent speed figures here and no CPU load, so the device must be using hardware offloading. That makes me want to test quality of service, you remember? On OpenWrt we can currently not use QoS, SQM, smart queuing and quality of service together with hardware offloading. It's either the one or the other. At the time of making this video, that means in November 2021. But let's do that after the Wi-Fi tests. The device can do 80 MHz channel width in the 5 GHz band. That means a theoretical maximum speed of 866 megabits. So realistically, I would expect something around the 500 to maybe 600 megabit speed here, with one client. Here is the test scenario explained quickly again. One server is running iPerf3 on ports 5201 and 5202. My iPhone is running iPerf3 in client mode and is connecting to one of those server instances, and my laptop to the other one. First with one device. As you can see, we do get, I'd say, a quite stable 400 to maybe 500 megabits. In the beginning of the test, I have been moving around with the phone. Not too bad. The interesting thing here is that the device only shows roughly 20% CPU usage. Let's add the second Wi-Fi client. The impact is immediate and obvious. The total performance drops to something like 300 megabits, 200 on one and below 100 on the other client. Not so good, but still okay, given that we're pumping a constant data stream over both clients. Cool. So much for the tests with stock firmware. I'm curious to see how we will perform with a full OpenWrt install, given that there will be a different environment from a Linux kernel and driver perspective. But before we do that, let's look around a bit on the device now that we have this nice shell access. The first thing I did before I implemented the exploit was running nmap against the router in order to see which ports are open. Open ports on a router can be a red flag for a network administrator, as every single application that has an open port could potentially increase the vulnerability of the device. From the LAN side, we can see a lot of open ports here. I'm curious to see what they do. From the WAN side, all ports seem to be closed. That's okay. Once I implemented OpenWrt Invasion, it does of course show additional open ports, namely TCP ports 21 for FTP, 22 for SSH and 23 for Telnet. Let's Telnet into the router and first query some basic variables. The proc file system will be our friend here. Also, there are a couple of tools like uname, netstat and lspci, which can give us further information. First, the kernel version. It looks like the router is running on a version 3 Linux kernel. lspci shows 4 devices. That will be the Ethernet cards, apparently there are 2 of them, then the 2.4 GHz Wi-Fi and the 5 GHz Wi-Fi. That's it. Let's see which modules we have loaded. We can see the usual modules like the drivers for the MediaTek hardware, but also some other ones like VoIP SIP support. Let's check the running processes. There are a couple of processes here that you would not find on the standard OpenWrt installation. We'll see in a second what they do. Also, I can see here that the router pings an API host every 2 minutes. That's actually an Amazon Cloud hosted instance here. Next, let's see the listening ports here. Whoa! Loads of open ports and applications listening. Let's see if there are established connections to the internet. In other words, let's see if the device is phoning home. Big surprise! There seems to be an active MQTT connection to this address here. Looking it up with NSLookup, it shows yet another Amazon Cloud instance. I have also tried to subscribe to that MQTT server with Mosquito Sub, which works but yields no result if I listen to the hash topic. So at least not everyone can listen into the traffic that my router sends to that address. But what does it use it for? Presumably, this is the communication channel to the app, which the router starting page invited me to download. Let me explain that quickly. These days, people expect consumer hardware to be accessible via an app on their mobile phones, be it checking the webcam at home, or checking or adjusting the temperature of a thermostat, or, like in this case, the Wi-Fi router. In technical terms, this is quite easy to achieve when you are in the same network. For example, if you are at home and you are in the home Wi-Fi. But people expect this to work everywhere in the internet. The problem is that it is not easy to get into your home network from the outside. That's what firewalls are for. You could, of course, use a technology called port forward, which would mean open a small window on your firewall, but this is quite hard to secure. It requires strict firewall rules, additional authentication, and dynamic DNS in order to find the home network from the internet. So how to solve this dilemma? Vendors have started to attach cloud-based services to their products. The way this works is that rather than trying to go into your network from the outside, the device which you want to control phones home, or in technical terms, it connects to a well-known instance in the internet. The app which they provide to you connects to the same instance. It's kind of a proxy or relay configuration. Both connections are outbound, hence no hindering firewall. You do something in the app, send it to that cloud server, and that server uses the established connection to relay the command. So, is this a problem? And if yes, why? Well, in my personal opinion, it's not a problem at all, as long as you are aware of it and you consent to it. In other words, you need to be okay with the fact that someone else controls your device. If you know all the facts, like who is using your data for what and how long they are using it, and you make an educated decision that this is what you want, that's totally okay. But wait, I am a citizen of the European Union and I am protected by the General Data Protection Regulation, the GDPR. That means that I have rights here. They should have told me about all this, have they? Yes, they have. You remember the very first screen when I set this router up? It asked me to agree to their user agreement and privacy policy. Luckily, I kept a copy. And screening it, yes, they tell me, Mark, we are collecting your personal information. And here is how we use it. They also do have a representative in the European Union who I can contact if I have any concerns. Guys, I'm not a lawyer, right? This is a tech channel. Just be aware that if you are using this router with stock firmware, then you are transmitting data to them, right? Looking around, I found a couple of things like that messaging task, which connects via MQTT to the AWS instance, the constant ping, some firewall rules which would open ports on the WAN side, and of course, yes, this router is running a heavily customized version of OpenWrt. We can, for example, use the UCI command to query the OpenWrt config data. One thing that has particularly intrigued me is the fact that the router can do quality of service, QoS, with apparently 0% CPU utilization. Actually, there is a Lua script running which seems to be responsible for this. I might have a closer look at that in the near future. Okay, I do not want my router or webcams or thermostats or any device in my home to be accessed or controlled by any third party. Hence, I will go ahead and flash the device with the real thing, with fully flashed OpenWrt. Right after this, call to action. I need you to get involved, please. I would like to hear from you if you are using cloud-controlled devices like IoT devices, so thermostats, cameras, etc., and if you do have any concerns about security or privacy. I would also love to hear from you what your take is on having a router being controlled over the internet or by a third party. Please do leave me a comment. Many thanks, guys. Before I flash the router though, I want to take a backup of the existing firmware. Usually I would do this on a USB stick. Since the device has no USB port, I need a different way of pulling an image of the firmware here. I could mount a volume on my NAS or over NFS or write into a file on the temp file system and then download it with FTP. But ad hoc I can also just use NC or netcat and pipe the output of the DD or cat command to a network socket on my local host. Let me show you an example of how this works. On the router, I do something like, for example, just print hello or output a text file, and then I pipe it over to NC, which expects a counterpart on this IP address on port, let's say 10,000. On my workstation, which actually has the IP address which I just specified on the other end, I let netcat listen on that port 10,000 and ta-da, the content is sent over from the file to my local workstation over the network. So I'll do that with the content of the MTD block devices, which do actually contain the firmware, and write the output into a file. If I have something to generate hashes like MD5 or SHA-256, I can even verify the content on both sides and make sure that I have an accurate copy. In this case, the checksum will always vary on the MTD7 device because this is a read-write overlay file system, and also on the MTD0 because that one contains all the other MTD blocks. The other checksums are okay. Cool. We have a backup of the original firmware. Now let's go and flash. The process is very well documented on the OpenWrt website. All we have to do is pull an image over the web using curl or SCP or FTP to the router and then write it into the MTD block devices. Let's go. This process takes a couple of minutes, but once the router has rebooted, then it will run OpenWrt and hence be available under the 192.168.1.1 address. As I have installed the snapshot image, I will have to install the web frontend manually. I can do so by SSHing into the router, then I launch opackage update in order to update the software package list from the OpenWrt repository, and then I do an opackage install Lucy. Lucy is the name of the web frontend. If you use a release image, this will already be included and you can safely skip that step. For the speed tests later, we will need htop in order to monitor the CPU usage. So let me also run opackage install htop to get that. Just checking that Lucy, the OpenWrt web interface, is available on the IP address 192.168.1.1. All working, all good. By the way, if I want this to look a bit more modern, then I go to System, then Software, and I search for Theme. The look and feel of Lucy can be adapted with themes. For example, the OpenWrt 2020 theme makes it look a bit more, modern. But now let's go for the performance tests. Same scenario like with the stock firmware or in the previous video. First, the switch test. That means both endpoints are connected to the LAN 1 and LAN 2 interfaces, and I run iperf3 in order to measure the Ethernet throughput without routing. In the same subnet, we can see that we get roughly the same performance like with the stock firmware here and 0% CPU. Now the routing test. No surprise, the performance is not great as it uses the CPU. We can see the CPU usage here in HTOP. So let's enable software offloading in Lucy under Network, then Firewall. Yes, this is much better. Last but not least, I tick the hardware offloading box, and that gives roughly the same performance like with the stock firmware. But keep in mind that Smart Queue Management, SQM, and Quality of Service, QoS, will presumably be unusable as of now. One more test to go, the Wi-Fi performance test. I have two iPerf3 server instances running on ports 5201 and 5202 on my Proxmox server, and then I connect via the Wi-Fi with my laptop and later with the iPhone. Both will run iPerf3 in client mode. One on the 5201 port, the other one on the 5202 port. Connecting the first client, roughly the same throughput like with stock firmware, but with higher CPU usage. Connecting the second client, and the throughput drops to 200 megabits on one and roughly 100 megabit on the second. Quite similar to stock again. Awesome, let's sum up quickly. I have summarized the findings here in this table. The performance of stock firmware and full OpenWrt are about the same, but with higher CPU usage on OpenWrt. With regards to the built-in data collection and cloud management capabilities of the router, I have decided that there is no way that I would use the stock firmware, but rather be in control and use OpenWrt. And again, guys, I have decided this for myself. I'm not your dad, at least to the vast majority of you. So you are of course totally free to decide for yourselves. Given the fact that the device only has 2 LAN ports and a WAN port, so 3 Ethernet ports in total, the use case as a router and switch might be limited, but it definitely makes a good access point. Comparing it to the D-Link DIR 2660, which I tested in the last video, it turns out that the device performs not so good. I'd say at 80 to 90% of the D-Link's performance. But hey, it only costs a fraction of the D-Link's price. The D-Link sells for $100 to $150, while the Xiaomi can be bought for roughly $30. So given the huge price difference, I think it's definitely a go if the limitations like the number of Ethernet ports, maximum of 867 megabits on the 5 GHz band, the missing wall mount and the missing USB ports are not a showstopper for you. I also checked if the Wi-Fi hardware supports mesh point mode, and it does. So a good use case could be to actually use the device as a mesh point in a 5 GHz mesh. I might make a video on that shortly. So far for this episode, guys. Do not forget to leave me a like and a comment and to subscribe so that you won't miss out on the next episodes. Until then, many thanks for watching. Stay safe, stay healthy. Bye for now.